Hello everyone and welcome to another simple science video. And in this video we're going to look at work done in expanding gases, and it's in the chapter Work, Energy and Power. Now this video is very quick to explain a very quick concept. Now look at this building. It is being destroyed by explosive, and buildings can be destroyed by explosive. We've seen them in the past. And how do explosive destroy buildings? It releases quantities of gases at high pressure. And these gases at high pressures are capable of destroying buildings. And as these gases expand, it is seen as doing work on the building. It's breaking down the building. It's pushing on its walls. It's demolishing the building. Okay? So this is basically based on the concept of gases expanding and doing work. Okay, so we're going to start to derive some particular equations that are very important to this concept. Now let's look at this frictionless piston of area A. It has a cross-sectional area of A, and it is acted on by a pressure from the atmosphere, the pressure P. We're letting it freely being pushed around by the atmosphere. Okay, and for some particular reason, or one way or another, the pressure inside the gas is greater than the pressure of the atmosphere, and therefore this gas will push out onto the piston against the atmosphere. Okay? It's going to push out because the pressure of the gas is greater than that of the atmosphere. That's very normal, and it pushes it out with a distance x. It pushes the piston out of the distance x, and it does this until the pressure of the gas is equal to the pressure of the atmosphere. At this point, the piston is in equilibrium, and there's no net movement, there's no net forces acting on the piston. And this process of moving the piston by expanding gases, we thereby seeing the gas as doing work on the piston. Okay? Now we know that the pressure of the gas inside the piston is equal to force over area, the force in which it exerts on the piston divided by the area on which it exerts, which we know of that formula. We can then arrange it to give force is equal to pressure times area. Now we know that when a gas expands, the piston moves with distance x. Now when there's work done of a gas, therefore is equal to the force times distance moved. So we know F equals pressure times area, as we have derived in the second box above. So force equals pressure times area. So force times distance gives you pressure times area times distance. And I'm going to call distance delta x because you are changing the distance. So as you can look from the diagram, the area multiplied by x actually gives you the volume. So the difference in the volume before the expansion is basically delta V. And therefore, we come up with a very important equation, that is work done is equal to pressure times change in volume. Okay? Now, reminder that the gas is expanding at a constant pressure. So throughout this process, P is constant. It's always trying to attain the pressure of the atmosphere. So that's why P is constant. And usually it's the atmospheric pressure if you are allowing it to expand and contract freely. Okay? It's usually the atmospheric pressure. Okay. Now let's look at this quick example. A gas expands with a constant pressure against the atmosphere, freely expanding in a piston of a cross-sectional area of 0.2 meters squared. Now find the work done by the gas as it moves the piston by 20 centimeters. So we know that work done is equal to the constant pressure multiplied by the change in volume. And the change in volume is equal to the cross-sectional area multiplied by the distance moved. And that is 0.04 meters cubed. And we know the work done is equal to pressure times by change in volume. And that should give you us 100,000 pascals multiplied by the change in volume, 0.04 meters cubed, and that should give us about 4,040 joules. So the gas has done 4,040 joules of work on the piston, on the system. Okay? Now, a quick reminder, if a gas contracts, then we see it as doing negative work, or simply the work done is on the gas. There's work done on the gas by the atmosphere, by the piston, whatever the two things that you have to call it, the atmosphere or the piston. Okay? I hope this video was instructive, and have a nice day.